Ready? It says it's live, which is a good sign. It's alive.
It's alive. It's alive.
Oh my gosh,
How
it
much fun are we
is.
going to have today?
Today we are definitely gonna have a lot today for sure because I know we're streaming live on YouTube and I'm waiting for it to pick up on LinkedIn. So it's gonna get there eventually once it comes in.
Yep.
It may take a minute, but we'll see how that goes. But I think today is gonna be interesting. Well, I'm trying not to be that scared today, but
This is kind of a scary setup, though.
it is. It is. You did a good job. You definitely did a good job. And I think we're live on LinkedIn as well. All right, so we've got everything running. So technology works for us. That's the first part. That's the scariest part, I think. Always the scariest part. It doesn't matter Halloween or not,
Yes, it
but
is.
making sure that technology works for us and it actually, happens at the time it's supposed to. Perfect. So we're off to a good start because I know we have LinkedIn is live, YouTube is live, and we have everybody just now coming in. So I'm gonna give them like 5 minutes or so, 2 minutes, 5 minutes. It depends. How much should we give them? How many heartbeats should we give them?
Well,
Staying in team.
we'll get in the mood. I'll give them my spooky laugh.
Oh my gosh, yeah, for sure. Well, I think we're ready. We're definitely ready.
I'm ready.
We are ready because I know we have Ahmed joining us, Greg, Kristen joining us, William Sloan already in on LinkedIn, and today we have a special Halloween edition, which because of the dates we have a lot of scary things going on, and Rich is in a very scary place right now. But I will not be joining him in that place. I will stay where it's bright and light and all good in that area. But I know as well for the Hindu community, it is Diwali because in Trinidad we celebrate that. So Shubh Diwali to all of our Hindu friends and
Yes.
listeners as well. I'm glad you could join us on the holiday because I know today's a busy day for a lot of people who are celebrating Diwali. And for those of us that are celebrating Halloween, you had Rich's introductory laugh to start off the session.
I'm ready.
Yes. So the GreaseThief is ready. And we're going to get started on this Halloween edition. I know we're going to be talking about, all of the different ways that we could have these gruesome deaths with, grease lubricated machinery. And that is also a very scary thing that happens throughout the year. And unfortunately, for these types of machinery, they don't get a break. Like there are killers out there, and there are people who do so many different things to them. So we have to be kind to them. We have to try to be kind to them. And Rich is gonna take us through just five of the most popular ones. But that doesn't mean that those are the only ones.
That's right.
Definitely other things can happen, and it's never fun for them. So we're gonna take you through a bit of that, and Rich is gonna help us out. I will jump in where it's not that scary.
And we want some audience
Oh,
participation
for
today. So
sure.
I'm going to be setting the stage, and I'm going to be
Mm-hmm.
telling the scary stories, and then I'm going to ask for suggestions.
Yeah,
How do we get by that? How do we get around it? So hopefully we'll have some people kind of typing in their suggestions so that you could read them
definitely.
out to me, or
For
if
sure.
not, you can Sonia, come up with your own
I will.
solutions and ideas. But let's get started. All right.
Yeah, for sure.
Great. Okay, I have 5 scary Grease stories to tell today. The first is the killer has a gun. And we know there are guns involved in
Yes.
greasing. Yep.
Always.
Next is the telltale bearing,
Mm.
a take on a familiar horror story from Edgar Allan Poe. And then we have the turn of the screw. Then we get on to Up in Smoke. And finally, the dirty little secret. So I hope everybody's ready. Let's get started. So, machine death number 1. The killer has a gun. And this unsuspecting motor thought the guy with the gun was a friend. But little did it know that Jack the Pumper, that's a new character we have now, Jack the Pumper, had a grease gun and wouldn't stop until he saw fluids oozing from the machine. And so, I ask you, how would you stop this killer?
Well, the first thing I'll do is I'll run very far away from him because he looks extremely scary.
Yes,
And
he does.
I will not you will not see me there very close to him. But that's my first thing. Definitely my
He's
first thing.
holding some other pumpkin's head, so we're off to a
Yeah,
bad start.
yeah, definitely. So he's not afraid to use that gun in any way that he can. So I don't know what he did to that other pumpkin, but I'm looking to see what our audience would say because I want them to, help us out with how they could actually stop this killer. But the first thing I'll do is run very far away from him and stay away from him. Lock the doors, hope for the best.
I think the scariest picture here, though,
Hmm.
is right to the right there.
Yeah.
Is the motor windings filled with grease, and I think most of us have seen this before. It's
All
a
the
scary
time.
thing, and when we look at that, we think about who held the gun, who
Yeah.
who killed that motor, and it could be a serious problem. That motor could be involved in very critical
Hmm.
applications. It could be supporting life type decisions for machinery and also for whatever it serves. The motor could be in a hospital. It could be
Yes.
in your plant. So a lot of scary outcomes there. But yeah, I'd like to hear what people would want to do about that. If they saw
Yeah.
this, what are the fixes? I know if our friend Alan was here, he'd have an answer
Oh,
for us.
he would definitely have an answer for us.
Oh, I think I see a good answer coming up in the comments.
Oh, we could use some ultrasound technologies. Thank you, Julie.
Yes, yes, Julie is right.
Oh,
Julie Julie just completed her ICML MLA certification. So
well done, Julie. So
yeah,
proud of you.
it's no surprise that she came right out with the right answer, and that's certainly a great thing, right? We know there's lots of good and not scary stories when you
Yes.
can marry those technologies together. Use ultrasound with the grease gun, but I'll tell you, there's a lot of Jack the Pumpers out there. There's a
Too
lot
many.
that don't have that tool,
Mm-hmm.
and I'll tell you, greasing is a scary thing because it's a mystery. You
Mm-hmm.
can't see what's happening. You attach the gun, you attach the fitting, you put it on the Zerk fitting, and you pump the handle and you hope for the best, or you pull the trigger of a battery operated system and you hope for the best. And I think some people look for that feedback. They want to see, they want to know that they've done something. And so they just keep going till it comes out
Here comes
somewhere.
yeah. That's their feedback.
And that's way too late. So ultrasound in real time, but sometimes the ultrasound can't be deployed, and that's when machines are not running or they're not
Right.
accessible while they're running. You need that running condition. So another thing that I want to introduce here is that we can do grease analysis.
Yeah.
So if we have a program in place, and with that we have a frequency established, then we come back and we sample at the end of that frequency. We take the grease that's being displaced at our set greasing frequency, and we evaluate it. We look for the condition. We look to see if the grease is hardening. We look to see if wear metals are accumulating. We look at the level of antioxidants, which we would
Mhm.
find how, Sonia?
And the ruler
In the
test.
ruler test. We apply the ruler test, and it all starts with a good sample. One of the scariest things for Julie and I in the laboratory is that a sample comes in and we have no idea how it was sampled.
Yeah.
And it's our job to analyze it, but it can be quite scary if the sample was taken incorrectly.
Yep.
And that's its own horror story there,
Oh
how
my gosh, yeah.
samples are taken.
And we also have Rohit. And thank you, Rohit, for getting up so early in the morning because I know it's like 5 a.m. on your side. He's talking about using the SKF calculator would be a good start if you don't have
Yes.
ultrasound technology,
Yes.
better than overgreasing, which is great. Thank you for mentioning that.
Yeah, it's a great idea. You have the
Mhm.
SKF. You can go to their website. You can use the calculators there. Amri has
Yes.
calculators like field calculators with circular, where you can kind of dial in and come up with a
Yes.
frequency and a quantity too. Right?
Mm-hmm.
Sometimes it's too often. Sometimes it's just simply too much.
Yep.
And he's right. Rohit's right that is a great place to start. And if we want to audit or evaluate how are our selected methods working, how are we doing with all of this?
Yep.
Well, grease sampling and analysis can give us that snapshot and
It
see where we
definitely
are.
can.
Yeah. Are you
Definitely.
ready to go on to the next
I'm
spooky story?
I am ready.
All right.
I'll keep myself ready.
Okay. The next one is the telltale bearing.
Oh.
We all know that story of the telltale
Mm.
heart, the tick, tick, ticking. But this is
Mhm.
the story of bearings that only tell part of the story, right? Because this story tells us about a vibration analyst, and they were keeping time as the bearing spun. They were telling a story of bearing distress. They could pick up frequencies. They saw impacting. They might have seen frequencies that correspond to the outer race
Mhm.
frequency based off of the speed and the size of the bearing. And we can get a lot of good information there.
Mhm.
But the question sometimes becomes what or who was causing that beat?
Yes.
And sometimes no one can say for sure.
Nobody
So,
wants to say.
yeah, and so they'll say it's a bad bearing.
Mhm.
Yeah. Just like, well, he was a good kid, but he made a wrong turn and then
Mhm.
became bad and a bad bearing. And what do you do for a bad bearing? Well, you put in a new bearing.
Yeah.
But if the killer is still on the loose, if we don't know what really caused those frequencies, this new bearing could suffer the same fate.
It
So
could.
how do you stop that killer, the unknown killer that doesn't reveal its face to the vibration
Mhm.
analyst?
Oh my gosh. I think you have to, the first thing you have to do is figure out, I would just map out where the killer is striking.
Mm,
Like, is he striking only in a particular area? Is it, just in the dry zone? Is it in the power plant area? Is it that he is restricted to some place? Try
yeah,
to map
find
him
that.
out.
Yeah, that common denominator, right? If we have multiple
Yeah.
failures, what is the common thread? As a good investigator would when they're on the case of the
Yes.
crime.
Because it is a huge crime. Bearings should not die like that.
I know, I know. Julie heard this last week when I was teaching the class, and or the week before, I think. And I said, bearings don't die; we kill them.
Yes,
Yep.
unfortunately.
Bad
Unfortunately.
practices, contaminated greases, too much, too little, wrong place, wrong kind of grease for the application.
Yes.
So a lot of times the vibration tells us more about this the symptoms,
Mm-hmm.
and what has been damaged, but not always the why. And that's where we
Right.
need other tools. And you gave us some good hints there, which is find the common thread if there's more than one. What are the conditions of operation that precede the failure?
Mm-hmm.
And back to grease analysis again, right?
Yeah.
If you have an outer race frequency, there's defects. Those defects got initiated at some point. Maybe they're because there's dirt and contamination in the grease. And
Yeah.
then you start a fatigue process. You have spalling taking place. It's another scary
Scary.
term.
Very, very
Yes,
scary.
bearing spalling. And once you see that, eventually, then you'll pick up those vibration signals.
Mm-hmm.
You'll hear that tick, 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 that a synchronous indication, in a synchronous multiple of the shaft running speed. So to me, this is where we can bring the technologies together to solve the crime,
Yes.
right? If you have an investigator, they don't just, you know, do one thing. They don't
All
take
right.
fingerprints and base the whole case on the fingerprints. They look at the DNA and they collect blood
Mm-hmm.
samples and hair and everything else they have to do to solve the crime. So,
At
yeah.
that crime
So,
scene.
yeah. So, so it sounds like it's mostly you and me. We got a couple good comments out there,
Yeah.
but yeah, for this one, let's just not get caught up on one technology, right?
Mm-hmm.
Let's look a little deeper and find out what else inputs that we can learn. What data can we
Yeah.
analyze to figure out the root cause?
Because the root causes, if you don't stop the root causes, you're not going to stop the killer.
That's
And
right.
your bearings are going to die continuously. And nobody wants their bearings dying continuously.
Yep.
So let's try and stop that killer for
Yeah,
sure.
what's that? Insanity, right? Insanity
Yes.
is doing the same thing and expecting a different result.
Oh,
So
yeah.
if it's just changing out the bearing, we just buy a little
Hmm.
more time, but we've
Yes.
doomed that new bearing to
We
death.
did. We did.
Yes, yes. You ready
Don't
for the
do it.
next one?
Yes. Yes. We are.
Okay. The next
Oh,
one
boy.
is this one is really kind of a narrow focus here. I chose one that
Hmm.
maybe doesn't apply to everybody, but to those it does, it can have significant impact. And
Yes.
this is the turn of the screw. And what I'm talking about here is the motor operated valve. The motor
Hmm.
operated valve. Really critical in nuclear power plants, in
Yes.
petrochemical facilities, some other kind of power plants. It's the thing that allows us to stay back from a dangerous process in a
Hmm.
safe control room, press a button and open or close a valve or regulate it to where it needs to be. But they're tricky devices. They're
Yep.
tricky devices. Okay, so here's the story of the turn of the screw. Keeping that MOV running was harder than they thought. Measuring the motor torque failed to tell the whole story. That's one of the
Hmm.
key tests that is used. We look at the power signal from the
Yep.
motor to detect issues in that entire drivetrain, if you will, that entire process of motor coupled to a gear, and then the gear driving a worm gear, and the worm gear spinning a stem nut, and the stem nut spinning the stem and making it go up and down, and then the seating of the valve and the back seating of the valve. So motor torque is very, very helpful. And if, of course, if our friend Howard Penrose were here,
Oh my gosh. Yes.
he would break that down and tell you all the different things that you can learn from that.
The dark
But
himself.
here in this story, they greased the valve stem, but still saw the stem nut die. The symptoms were there. So something different was needed, and they searched for new tools to protect the rest. So
Hmm.
how would you stop that killer?
Oh my gosh. I think the first thing we need to do is call Howard in.
Yeah,
Like,
or
that's the first thing I would do.
yeah, or maybe some of our friends that work in nuclear power who've
Oh
spent
yeah.
years looking, at the diagnostics for these things, and then have had to deal with failures that happen even when you're carefully monitoring the system.
Yeah.
So yeah, there is a very very tricky thing here, and I had an old friend visit me yesterday from the nuclear power industry, Brian Reese, and we looked at a couple of motor operated valves that I have in my laboratory.
Wow.
Yeah, not in this basement lab, but in our main laboratory. And there we have been testing those motor operated valves and testing the stem and the stem nut. It's a critical interface,
Mm-hmm.
and there's been issues that the nuclear power industry has had to deal with. And so I was sitting at a table one time with two engineers, and they said, some of these valve stems really don't move very much. They don't move up very far. Maybe a butterfly valve only turns 90 degrees, so the stem never really rises up out of the stem nut. So how do you get the grease in there? Like if you can, you put the stem all the way up, You coat it with grease and then you run it back down into the nut. So for that particular challenge, we've developed a device called the
Yes.
stem thief. The stem thief.
Mm-hmm.
Just another cousin to the grease thief, and it attaches to the top of the MOV stem, creates a sealed chamber, and then a regular grease gun can be used to force grease down into the
Right.
threads, around, circling around the stem nut, pushing the old grease out, and putting a fresh layer of grease in there.
And that is very important because we need that fresh layer of grease, just to kind of make sure that things happen.
Oh yeah, yep. And so our friends over at Palo Verde Nuclear Power Plant have been using this, and they came to the motor operated valve users group
Right.
and told their story. And their story wasn't scary at all. Their story was a celebration of improved lubrication, where they used the stem thief to relubricate these greased stem and stem nuts, and they found the coefficient of friction dropping from
Right.
0.15 to 0.10. So
Wow.
more than 30% drop in the coefficient of friction. And once you restore that protective layer of grease, now
Mm-hmm.
your wear decreases, the life increases, the reliability is improved, and you have more confidence that that component is going to do what it needs to do when you need it.
Mm-hmm. And that's the confidence that we need because we're operating very critical machines here.
Yes.
So getting that friction level down could increase your overall efficiency by so much. Like, that's a lot that it can go down by. So it's definitely something that you need to look into. And I know we talked about the stem teeth on this series before a little bit, but something you should definitely check out for sure.
Yeah, and Linda Perry brings up a good point. You know,
Yes.
she says it always reverts to grease testing, right? And
Yep.
when you do relubricate an MOV valve stem with the stem thief, it does displace the old grease and
Hmm.
put it right where you can get it. And so it's a method of sampling as well. And now you have the representation of what is going on with the grease, what's going on with the brass stem nut with the steel stem. All that information is there in grease analysis, and you can get to it, which is good.
Yes, that's the important part, getting to it and making sure you have the right sample because that tells you what's going on the inside.
Yes.
So that's the important part. I know Jeff Walkup is actually asking about some of the advantages or the pros and cons of using acoustics when greasing.
Yeah, he brings up a good point, and I think we're going to go into the monsters right after this.
Ah,
We're going to go into
okay.
the monsters to avoid, and we'll circle back to Jeff's comment there because I think it's a good one and something that deserves a little more, the pros and cons really, which
Hmm.
because it's kind of put out there as a universal solution, but what do we have to consider if we're
Yep.
doing that? So let's go to the next one.
Oh boy. Number four. Oh
Unfortunately,
my
number
God.
4 is up in smoke. Up in smoke.
Oh yes, happens all the time.
Yeah. So it says a serial killer was working its way through the manufacturer's critical motors, but every crime scene looked different at first. There was
Hmm.
burning paint, then a locked rotor failure, right? So that's that.
Yeah.
You say what caused this machine to stop, and finally a disappearing bearing,
What?
like magic. But
Yeah.
there was a common thread that tied them all together. And
What could
I,
tie them? What could tie all of these guys together going
yeah,
up in smoke?
well, I gave a hint. Something's in quotes there. A
Oh,
common
yeah.
thread.
I wonder if our audience can guess the common thread here. Let me make sure and see if they can guess what it can be. He says, Jeff says it's the boogeyman.
Oh, yes, of course.
It probably is. Like I agree. Like that's the only thing that makes sense, right?
I think there's plenty of maintenance departments that'll kind of refer to that without any real evidence, right? Why are
Hmm.
these things failing? Well, it's
Uh,
probably, and insert villain here, right?
Yep, definitely.
Unless we dig deeper and we find some data. So this is a real life example that I had. I had
Boy.
three different motors sent to our laboratory for root cause failure analysis. And it was a rash of failures all happened at once, each from a critical component, not big motors either. These were like 5 horsepower motors, but they were
Wow.
critical applications. And like it says here, very different symptoms. And this is where we have to make sure that we don't get too focused on the symptoms,
Mm-hmm.
right? We've got to look past the symptoms and look for that common thread. So one of the things that was common with these motors is that they had been retrofitted with
Ah.
with a slip ring to discharge electrical current. So these were motors that had been retrofitted initially with variable frequency drives. So variable
Mm.
frequency drives were attached so they could regulate the speed. They could slow the motor down as needed to align it to the needs of the driven component. And then they put special rings on the shaft to dissipate the electrical current. Have you ever heard of that, where that's a concern, electrical discharge
I
through the bearing?
have.
Mm-hmm.
I have heard about it, and even you get that in oil analysis quite often as well.
Yep.
But it's something that pops up that sparks so much interest every now and again. But it's not the best thing to have happen to any piece of equipment because you're talking about 10,000 degrees Celsius, or you know that temperature going up to that far that quickly. So it's
Sure.
gonna burn a lot of things.
That electrical discharge, it burns the oil, burns the grease, and
Everything.
actually burns into the metal. It actually
Yeah.
discharges small pieces from the surface. So we get these kind of burned black oxides
Yep.
in the oil and grease. And I've noticed when I've seen this, when it's an oil
Mm-hmm.
lubricated surface or oil lubricated bearing, that the small black particles are almost spherical in shape
Mm,
because they're ejecting as a molten
right.
metal, and then they pull together within that interfacial tension with the oil. They pull into that spherical shape, and that cools it, and then you find these black little spheres all over. And I've seen it in grease as well, but they
Mm-hmm.
tend to be not quite the perfect spheres
Ah,
because they don't quite have the same effect in the grease. There's more of a lack of uniformity
yeah.
in the flow and so forth, and so they tend to be a little lopsided. But both of them come out as black oxides. So sometimes people, they focus on that and they say, well, it must be electrically related. It could be a
Mm,
discharge. What do we really have here? So we had to dig deeper and we had to
yeah.
find out what could cause these different things. I said burning paint, and this was pretty wild. The
Yeah.
outside paint had actually burned off in one area of that motor, and the locked rotor was you just couldn't turn the shaft anymore. And then the
Mm-hmm.
other one is the shaft was just moved up and down freely because the bearing was gone. And they seem like three very different situations until we pulled the motors apart.
Oh,
And in one, we found an accumulation of red dust. So, what does red dust indicate?
first thing I'm thinking about is iron.
Iron, yeah, yep,
Yeah.
and different forms of that iron oxide, right? So
Yeah.
you can have rust caused by water,
Right.
right? So you have that kind of scale rust that gets
Mm-hmm.
created, and that looks a certain way when we find that, like on a steel beam or something. You can pick away
Right.
at it, and these little platelets come off. It actually retains that into the microscopic range as well. Little red platelets due to like a
Yeah.
water induced rusting or corrosive red oxide. But there's another kind of red oxide that gets formed. And this
Mm.
one, when you look at it under the microscope, is very round and it's very uniform in size. And you see red and black and red and black and red and black.
Oh.
And that is typically indications of fretting wear.
Ah.
Yeah.
Okay.
So now you have an unlubricated surface and your metals are kind of slapping together.
Oh my God.
Yes.
That is scary.
So we saw that. We saw that. We also then tried to find out why this rotor was locked in place, and we also then saw where the another one had like damage, like scoring damage on the motor rotor. And when we went through that dust and as we dug through all the debris, we found a small screw.
Oh,
Now, now the thread is making some sense, right?
it is. It
Yeah.
is making some sense now. It's all coming together.
So we pulled this little screw out and really questioned why is the screw loose inside? And we looked for that grounding ring, and in one of the motors it had disappeared. It's supposed to be mounted with these screws to the housing. In fact,
Hmm.
these motors were purchased, sent to a contractor. The contractor was tasked with installing these grounding rings
Right.
and then brought them back to the customer. Well, what we found was these little screws were becoming loose and backing out. And that caused the lock rotor. It caused the scoring. It
Oh
caused the
my
paint
God.
to overheat. And caused all this red oxide to show up. One of them even fell into the bearing
Oh
and
my.
caused the entire bearing to eat itself
Yeah.
away. Yep. And so we had a loose screw, but we didn't know why, right?
Mm-hmm.
Until we looked at the thread of the screw and you could see
Right.
a material caught within the threads. We extracted
Oh.
that out, we analyzed it, and found that it was a graphite material. So now you got to go back and say, well, where does this come from?
Where?
What was the
Yeah.
task that was done? You know, what did they have in front of themselves? And here, what you find is that these kits to put these grounding rings on, they come with some grounding paste. And this
Oh
paste is
yeah.
graphite, and you put that on the brushes in the shaft to improve the conduction as
Right.
it spins. Unfortunately, in this case, it was made by a
Oh.
company called Loctite. Loctite is
Oh.
Loctite is a brand name, right? And they make a lot of
Mm-hmm.
different materials that are helpful for fasteners and other things. Unfortunately, the folks that installed these grounding rings thought that they went on the threads of the screws. And so
Ah.
this is a case of lubricating something that shouldn't be lubricated.
Oh
And
my.
that allowed those screws to back out, and it caused failure after failure after failure. They had different symptoms, but the
Mm-hmm.
root was the same. The serial
Yeah.
killer was graphite conducting paste being put on the threads of a fastener. And I think about this. We don't talk about
No.
fasteners very much
No, we
in
don't.
maintenance. And one person that does is Drew Troyer.
Yes.
You know Drew
Yeah.
Troyer, right? And he has a whole thing where he talks about flab, right?
Mm-hmm.
Fasteners, lubrication, alignment, and balancing, and he gets into how important fasteners are, and if we don't torque things properly, if we don't
Right.
have the right kind of thread, if the lock washer isn't what it needs to be, and in this case, if we're lubricating something that's not supposed to be lubricated,
Yep.
it can cause the damage. And so, yeah, root cause failure analysis.
Very
In,
important.
yeah, improper, too much lubricant where there's supposed to be none.
Oh my
Supposed to be
gosh.
none. So,
Yeah. So
all right.
we're getting some comments in here.
Okay, good.
Rohit is talking about thanks for mentioning the router issue. We just had a motor on site with the router bar issues, which was picked up from vibration analysis,
Mm,
which is good.
yep.
The motor was actually sitting in their store for more than a decade. So,
Mm,
having that in there, and I know Rohit had sent some information to me, good information, good analysis on what he did, but definitely something we need to take care of.
yeah.
And I know Jeff is actually talking about he's thinking about when, use an example as a wind turbine is about to shut down to the low wind speed, and
Mm.
you're trying to grease the others at the bottom. And then over time, the metal to metal surface contact, you would have milliamps
Oh.
of electric discharge going through the system.
Yes, right. It's
Yeah.
it's an electrical generating component, and we got to think
Mhm.
about where is that power going. Ideally,
Yes.
it transfers right through the wires in the way that it should, and it becomes power. But he's right. It's always a risk, whether it's a motor or a generator. We need to be concerned about those electrical currents doing damage.
Always.
Yeah, I think
Electricity is
also.
scary.
Yeah, it's scary. Yeah, I also Rohit, he makes a good point about long-term
Hmm.
storage. I know that we had an organization that they had a lot of spares. It
Right.
was part of, and this was a marine application, so they had a lot of spares
Mm.
where they could swap them out as needed as time went on. And he mentions more than a decade. That's what was happening here. That
Yeah.
these bearings, these greased bearings, were in storage, and you just, when you need it, you go get it, right? But
Hmm.
what is the condition of the grease
Yeah.
after 10 years of storage? and
My
and he
God.
makes a very good point, and we found that that was certainly a risk. There was some separation of
Hmm.
oil and thickener, and certainly the more vibration that's in the storage area, the more likely that is
Yes.
to take place. So I think he raises a really good point that we can all be thinking about.
Hmm.
These scary stories, they start with the mayhem and the damage and the death, but we have to dig through and investigate and
Yeah.
solve the crime if we don't want it to come back and hurt us. And sometimes it's like it says, it's due to extended periods of storage.
Yep.
And you know, I when I do the training classes, I bring this up quite a bit, that the most underserved community, I think, when it comes to lubrication knowledge, is the purchasing and storeroom folks.
Yes.
It's a big missing piece. It's a big missing piece. And I was fortunate a couple weeks ago to have somebody that had that responsibility to be in one
Mm,
of my classes. I said, I've been
yeah.
waiting. I've been waiting for you.
Yes.
Send your colleagues. We want to share this
Oh
information.
my gosh.
Things like, oh, I found a less expensive
Mm,
hydraulic fluid, so we're just going to substitute A for B, or
no, don't
greases,
do
right?
that. Don't do that. You're
Yeah, yeah.
you're introducing more colors in there.
Yeah. It's in an effort to get the lower price, we end up with greater cost.
Yes,
And
definitely.
we if we can connect those dots for folks, it certainly can make a big difference.
A huge difference. Definitely.
Yeah.
Are we ready for number five?
Yes, let's go. Let's
Brace
see.
myself.
The final death we have to talk about is the dirty little secret.
Hmm.
The dirty little secret. So the company decided to improve performance by switching to the premium
Oh,
grease. Okay.
nice.
Knowing that you get what you pay for, right? So this is the opposite of what we just said. Someone
Mm-hmm.
trying to save a buck by going to a lower cost lubricant, they went to the premium grease. So
Mm.
they were shocked when the infant mortality was getting
Mm.
worse rather than better. Yeah. So we'll just play on that infant mortality a little bit,
Yeah.
make it even scarier. We have to save the children.
Yes,
But
always.
what more could they do? The answer was lying in wait in the brand new grease that they thought was a solution to save them.
My
So how
God.
would you save them?
Save the children. Always save the
Yes.
children. Children first.
So what would you do, and what would you investigate? And is just changing to a premium grease the answer to our
Yeah.
problems?
There are so many things I'm thinking about. Like, did we check what we had in there before?
Okay.
Like, are we having compatibility issues?
Ah, yes. A
Like
really
that.
good point, right?
That's what I'm thinking.
Right. So that's a really good point. I like that one. Grease compatibility. And William says the same thing
Hmm.
as you were getting that out. He says grease compatibility analysis, right? It's a good
Yeah.
one. And that can be, and I've seen that happen if we're not careful. What is the compatibility between the old grease and the new grease? Or
Yeah.
if we find that it's not, are we really doing a good job of getting
Mm.
all the old grease out of there when
Yes.
we put the new in. So a good thing to think about. It was not the issue
Oh,
in this particular
okay.
story, though. So I ask
Hmm.
you to dig deeper. I love the way people are thinking, though, because that's a great thing
Yes.
to check. Linda reinforces what
Yeah,
William says.
definitely.
Yeah.
I am thinking if we don't have a compatibility issue, are we using the right grease?
Yeah, just because it says premium
It doesn't
doesn't
mean
mean
that it
it's
has to be the
correct.
right one.
Yes. And if I had chosen a different story for you, I could tell that
Mhm.
one.
Yeah.
We indeed had a customer that said we've changed to premium grease, and I said,
Mm.
"Well, what's that?" Or sometimes you hear we're we're going to change it to a high temp grease, right? Because
Mm.
we want to protect against higher temperatures. That's not what a high temp grease is. A high
Oh.
temp grease has a thickener with a known performance into the temperature range, but also will typically
Mhm.
have a base oil with much higher viscosity to counteract those higher temperatures, right?
Mm.
So my experience with that was they went from a 120 centistoke base oil to a 1500 centistoke base oil.
Wow.
Yeah, and then they started having
That's
failure.
one way to kill them.
Yep, and it was they said, "Hey, we don't understand. It's a premium grease. It's
Mm-hmm.
premium. It's just not right for the application."
Yes.
But that
Long.
also is not the answer to this dirty little secret.
Hmm. I'm thinking contamination.
Yeah, right. I gave you a
I'm
hint in the
thinking
title. So
contamination.
let me tell this scary story. So there was a grease manufacturer, boys and girls,
Mm-hmm.
a, a, a grease manufacturer that was seen as a premium manufacturer of
Oh.
greases. And they sent us some samples. They said their customer was complaining that the grease was causing their failures. And so we
Hmm.
analyzed it and we found high ferrous content. So we did what tests would we do then to find out what kind of particles they are?
We're going in the feral queue.
Well, we put them in the
Like,
ferroQ, right? And we
mm-hmm.
found that it's higher than expected. And then how do you
Hmm.
find out what type of particles they are?
Hmm. You have to check the wear particle analysis.
Yes, analytical ferrography.
Yeah.
Yes. People
Going to
think that grease analysis is relatively new. Our friend Ray Daly taught me.
Oh, yes.
Yeah, he taught me how to do analytical ferrography on greases in, I'm going to date myself,
No.
1990. 1990. Yes, doing grease analysis all the way back then. So that's what we did in this case, in this dirty little secret case. We looked at
Mm-hmm.
that and we found gear wear. Gear
Oh.
wear. Yeah. Yeah. And gear wear is a flat but somewhat chunky particle that has
Mm-hmm.
drag marks on it, striation.
Right.
And so we identified that to the lubricant supplier, and they said, nope, it's not from a gear machine. So you are
Oh,
wrong,
oh
which was very
boy.
baffling. I felt very bad. I questioned myself. Maybe I don't
Mm-hmm.
know what I'm doing. But we said, can you send us some brand new grease? You're the grease manufacturer. Send us a
Mm-hmm.
brand new tube. Give us a chance to check that out. So we did. And what we found in the brand new grease was quite scary. Do you
Oh
know
my
what it
God.
was?
Was it
Gear,
good? Yeah.
gear particles in the brand new
Oh
grease.
my God.
Yes, because if you think about it, how we make greases, they're made in kettles. There's some continuous
Uh-huh.
process methods as well, but there's made into a kettle. And when the grease gets to the right consistency and the right
Right.
blending and it's ready to go, then it goes into the packaging. How does it get
Mm-hmm.
from the kettle tank to the packaging?
Oh,
A gear pump.
yes.
And this gear pump was in a state of failure.
Oh
So
my.
yes. And see, the reason it's a secret is, how do you see this? You look
Yeah.
at the grease, it's the same color. You can't
Mm-hmm.
hold it up to the light and see if any particles are shining back at you.
Yeah.
Some of those inspection tests that you can do for oil, you can't do for grease. And the only
Yes.
way to do it is to actually do particle evaluation
Mm-hmm.
of your new grease. See if it's dirty or clean. And if it's dirty, find out where those particles are coming from. Yeah. And Rohit says that as well. Yeah.
Yeah,
Yeah. Get it
definitely.
checked. Get that new grease checked.
Always,
Hmm.
always get it checked. Like
Yeah.
that's the important thing. You
Yeah,
need to get that checked. Protect your
right.
children.
And Elaine has a really good point, right? It's not like
Hmm.
you can filter the grease.
Yes.
Yeah. So we have to know that our greases are clean, and we can't know
Mm-hmm.
unless we test them. So I don't it's not something you have to do, every day, but
Yeah.
when you're getting shipments in, you can put a little aside, have it evaluated, see what the particle count is. And I think that's another thing that people don't know is that there is an ASTM standard for particle counting in
Yep.
greases. Yeah.
Mm-hmm.
And there's laboratories out there that have that capability with the GreaseThief analyzer. In fact,
Yes.
there's another one that one of our GreaseThief labs is now testing the particle counting and looking to
Ah,
add that to their stable of tests. So yeah,
nice.
it's exciting. The tools are out there. We just got to know they're there, and we got to use them, right?
Always. And part of that is awareness. So thank you for
Yeah.
bringing that awareness to us, Rich.
So we've got a few more minutes, and that is the five scary stories that I had to share. And now I'll tell you about the monsters we have to avoid.
God, yes.
You told me you don't like these monsters.
No, I don't. I'm not big fans of them, but I'm on this side of the screen, so I'm okay. I'm okay for
Well, we'll teach you ways to avoid them,
that.
right?
Okay, good.
Okay, so avoid the monsters and protect your grease machines. And the first monster is Frankenstein. And what is the legend of Frankenstein? What is the Frankenstein
Oh
monster when it
gosh.
comes to grease? Well, Frankenstein was put together of various parts, right? The head
Always.
was sewn on to the arm and everything else. And that's like putting your lubrication together piece by piece.
Yep.
Some grease here, some grease there. You end up with mixing greases. And we've
Never
said it,
fun.
it's a recipe for horror.
It
So
is.
if we can avoid the mixing mistake, then
Mm-hmm.
we can extend the life of the machinery. And sometimes I think people don't realize how mixing can come about. They, you
Yes.
know, they think, okay, yes, somebody grabbed the wrong grease gun and pumped it into the machine. But what about this? Some of our machines come with grease already in them.
Yep. Mm-hmm.
And if that grease is not what we are using, we just created a mixture.
We did
That's not really our fault.
unintentionally.
Yeah.
Mm-hmm.
And I actually saw this one time. I was at a facility and they brought in an outside contractor to
Wow.
align, to just do an alignment of a belt driven fan. And the individual did a fantastic job, did a laser
Mhm.
alignment, tensioned the belts, had everything looking good. And then he reached into his bag and pulled out a grease gun. I said, "What's that?" He
Mm.
says, "Wherever I go, I always grab my grease gun and I pump grease into all the fittings I can see, just just for good luck."
Yep. Good luck afterwards.
Yeah, good luck afterwards because, as you can imagine, I looked at his grease gun and the grease he was using, and it was not compatible with the greases that facility was using. So, whether you buy a new machine that has grease in it already, or you have contractors or someone else, maybe you send your motors back for rebuild, and then they come back with what in it. Who knows?
Oh boy, nobody knows.
Yeah, I
Again.
was yeah, I was at a place where they had an old planner that had been there
Mhm.
many, many years. And when he sent
Ah,
motors out to the rebuild shop, he duct taped the grease that they were using to the motor so that they would use it. And
yeah,
when he retired, guess what?
it went
Nobody,
away.
yeah, it went away. And they
It
started
went
having a
away.
rash of failures. So
Mm-hmm.
that's one way to avoid the monsters is don't
Yeah.
mix the greases. What about the zombies?
Oh God.
We got to give you nightmares.
Maybe. Maybe.
Yes, don't let your grease molecules become
Oh, God.
zombies, right? So
Yeah.
how does it happen in the zombie movie, right? One comes out and then bites the other one and they bite two
Yes.
more and it goes on
Yes.
and on and on. It runs away from us. And that's how
Yeah.
oxidation happens,
Yes,
right? So
definitely.
if I can scare people thinking about zombies when it comes to oxidation of grease molecules, then maybe we'll look at that more closely.
Yes.
And how do we find out if our protection against the zombies is depleted?
Oh, you always use that ruler test.
That's right.
Always use that ruler test.
Yep. The antioxidants are the key to slowing down that death spiral once it starts. And The way to measure that is indeed with the ruler test using greases. And by the way, the ruler test is part of ASTM D7918 for
Mm-hmm.
greases. So there's
Yes, it
specific
is.
method. There's also another method, I think that Fluid Tech helped to develop there as well.
Yes. Oh,
So the
yeah.
next monster is the
Staying
vampire.
away from that one.
Well, I like the analogy here because when we think about greases, there's a liquid part and a solid
There
part,
is.
and they got to be in the right ratio. And if they're not,
Mm-hmm.
then we have problems. Greases dry out, and that hardened grease causes failure. So
Yeah.
your grease, I mean, if we realize the grease is a careful blend of those oil and additives and thickeners, we have to stay away from the vampires that'll change that
Yes.
ratio, turn it into a hardened mess.
Mm-hmm.
And we can test this too. We can
Yeah.
test our in-service greases to see if they're holding up. Look at the frequency that we have been replenishing the grease at, and then do the dye extrusion test. Right.
Mm-hmm.
So if the dye extrusion test, I have a little thing in front. I can't see that, but that and I highlighted dye so it looked like
Yeah.
yeah,
I
dye.
died.
Yes. The dye extrusion tells us about the consistency, right? How
Mm-hmm.
much consistency is, if it's the same as the new grease, it's getting hard or it's getting soft and runny. So we can avoid those vampires that would tend to suck the oil out of our grease and dry it out.
Always avoid the vampires. Always.
Yes. And then the witches.
Oh my god.
The witches put a hex on your machines. And
Yes.
yes, and no matter what you do, they just keep failing.
Mm.
Okay. And they can be hard to spot, but you can't kill what you can't see. So if you're not
Yes.
testing, you don't rely on just one technology. This goes back to our
Mm-hmm.
vibration horror story, right?
Yeah.
Vibration is fantastic and it helps you monitor and look at the forces, but it might not be the only technology that you can
Yes.
use to understand what's in there. So grease analysis, vibration analysis together, they help you find the cause of death and eliminate that from the failures. None of these look friendly enough to you, do they?
No, no.
They're all cartoons. So the next one is werewolves. The mild mannered grease goes bad, right? It's just a
Mm.
harmless looking accountant with glasses, and then the
Yeah.
next thing it's a werewolf,
Mm.
right? And busting out of his shirt and everything else.
Oh
So
my
if you
gosh.
don't watch your grease for
Mhm.
changes, it will sneak up on you. That's always what happens
Mhm.
in the werewolf movies, right? They're there
Yes,
with the friend or the guy that never harms anybody, and then the moon comes out, and you're
that's
you're
it.
looking the wrong direction, and the werewolf
That's
gets you. So
yeah.
yeah. So what we need to do is monitor the greases for health by sampling and analysis periodically, right? You
Oh
keep
yeah.
that watchful eye.
Yes,
When you see
always.
something that's unexpected, get to it before your grease changes into a werewolf,
Nobody wants any of that running around their plant.
right?
Nobody.
One more monster is the gremlin. The gremlin. This is when I was growing up. The Gremlins movie came out,
Yeah.
and the gremlins live in your machines and they set you up for failure.
Hmm.
Sometimes machines are failing, and I don't know what it is. It has to be some little gremlin in there that's pulling and tugging on the
Yes.
wires and tearing things apart, but it never is, right? It's
Yeah.
always it's always what you set up in that machine.
Hmm.
So if you put in fresh grease and yet the gears and bearings are harmed, then we have to dig deeper and we
Yeah.
sample to find out what the root cause is. Test your grease to be
Yes.
sure that any changeover to another product or a new component doesn't bring gremlins along for the ride.
Nobody wants gremlins, right? Nobody wants that anywhere near their plant or anywhere else. Okay. It's
I
just
had
be
it. Yeah, no, it's true. It's true. I had an interesting one, which was a factory that made a feed product. So we say food for people and feed for animals, made a
right.
feed product. And we tested their grease. They were having some bearing failures, and we found microbial activity. Microbial activity. The
Ah,
microbes were in eating the grease. And then this becomes a concern. Does it get into that food or feed product?
right.
And of course, we don't want to eat any food or serve it
No.
to our pets if that's the case. But it's a gremlin because you can't make it go away just by regreasing. You're just
Hmm.
feeding that gremlin of the
Oh
microbes.
no.
And
Do
so you
not
got to get
feed
it.
them.
Yes,
Don't
you got to
feed
clean
them.
it out. It has to be cleaned out, and you have to inoculate it, and get the microbes killed, or else they'll
Hmm.
they'll continue to eat your grease and propagate.
Oh my
So,
gosh.
well, we try to shoot for an hour with this,
Yes,
and I wanted to
usually.
finish up here. It's all this scary story, but the Grease Thief is here to help. And we've talked in our
Definitely.
last one about all the labs around the world that are
Mm-hmm.
using the technology, all the things that they can help you find, detect. It's all standardized, right? It's all ASTM standards. The
Right.
sampling methods are ensured by the Grease Thief tools and ASTM D7718. So, how do we get started? What if this scared anybody today?
It did. It
In
scared me.
addition
I'm
in
just saying.
addition to you, Sonny, if there's any scared, asset owners out there that want to do something about it, it's a couple of simple steps. Choose your application, and then find the sampling kit that works in that application. Right? There's kits for. Jeff talked about wind turbines. There's wind
Yes.
turbine kits. There's pillow block. There's electric motors. We have them for robots now. So you match up
Yeah.
the sampling kit to the application, right? And if you're not sure, then you just reach out and we can answer that. We can ask questions about the device. It's a little bit different. We'll look at pictures, maybe drawings.
Mm-hmm.
Sometimes we'll even develop or invent a new tool. And we've
Yes.
done that before. Like we've talked
The
about the
GTA Mini.
yes, the GTA Mini. We've also talked about locomotive wheel bearings, right?
Mm-hmm.
And how we developed the Grease Thief Slim and the pickpocket
Right.
for that. So we can do that, and then you just get your screening kits and pick which ones need additional testing. Right? Dig deeper.
Sure.
You start with the ferro Q. You have ferrous wear,
Mm-hmm.
then you dig deeper to find out just what it is, so you know what to do about it. So and it's been growing, right? So
Yeah.
if your lab doesn't use the Grease Thief, ask them about it,
Yes.
and there may be options to add that to the slate of tests. So how are we doing on the questions that have come in?
Well, a lot of people love your costume. Let's just start there.
Yeah, I
A
can't.
lot of
I
people love it.
actually I actually got my hair. I look like a mad scientist, but I don't think you can really see it here in the dark. It's all
Mm, not
my
that,
wife.
not that.
My wife gave me a look. I had
Oh,
all
it's
my
not.
hair sticking up
I
like
can
a
see
mad
parts of
scientist.
it. I can see parts of it, but they
Yes.
definitely loved it. It's always great. Linda is saying it's always great learning. Ahmed loved the scary background and the accent and the style and the light. Rachel is coming in. Oh, we see your hair now.
Oh,
Yes,
yes,
yeah,
yes. Let me see it.
yeah.
Ah!
So it's they really enjoyed it. Elaine wants to know how bacteria grows in Greece.
Yeah, all bacteria needs is warmth, moisture, and something to eat. And something to eat is
Mhm.
organic, and greases are organic, right? Petroleum
Yes.
products. And so this is what happens. It just they first get in there, okay, and it doesn't take much, but then you create the conditions for them to thrive, especially in wet environments where like a paper mill or somewhere else where
Right.
there's wet environments, and that's where you'll see them grow. And if you and really this is one where we have the tools. Like it's the bad smell. If
Yes.
your grease starts to smell bad, like something died in there, then it's time
Something
to do the
died.
testing. Yeah, and there's tests for that too. There's a special test for greases to quantify the amount of ATP or adenosine triphosphate that is present
Oh,
in the grease. And when it's above background levels, now we know that that colony is growing and propagating, and it can cause problems.
all right. Thank you for clearing that up. Nobody
Yeah,
wants bacteria in their grease, in their
now
oil, in their systems anywhere. Nobody wants bacteria.
that's right.
And I think she said that clears it up for her.
Oh, good.
And some water can, yeah, water could definitely play a role as well, for
Yeah,
sure. Yeah. And we just had Rachel Godfrey said it was a great presentation. She really enjoyed it.
good.
We had Jeff coming in from time to time. Rohit was in as well. So a lot of Thanraj from Singapore, because I know it's 1 a.m. on his side.
Wow.
And yeah, he's asking, is it IP385?
Is the what does he mean, that the testing for the
I am not
microbes?
sure. I'm not
Yeah,
sure.
I'm
Maybe.
not sure either. If that's what he's asking, I can't answer that, but that would be something to check. The test that I'm talking about is an ATP testing, adenosine triphosphate. So it
Okay.
um, uses enzymes to break down the molecules. The bacteria or living organisms will release ATP, and then the sample will glow as ATP. It's the same
Ah.
thing that fireflies or
Mm-hmm.
glowworms that they use, that
Right.
the bioluminescence.
Yes.
But that's how you use that with a sensor that measures the luminosity. So yeah,
Mm.
and
Very
that may be
interesting.
it. That may be the international test. I'm just not familiar with that off the top of my head.
All right.
Yeah.
Yeah, I think he's asking if it's used in microbial tests.
Yeah, that's what it is.
Yeah.
It just takes a little bit of a enzyme and then this luciferase, and then you put it into something that measures the luminosity of that, and it tells you picograms of ATP per gram of grease.
All right.
Yeah.
And I know we have Ahmed here as well. I
Hmm.
missed him out, yeah, but I know Ahmed is, in and commenting.
Oh, great.
But I
Glad that
think
he's
that's
here.
I think that's about it for scary
Okay.
stories.
Super. And we'll review any of the questions that we missed
Yes,
and get back to people individually.
definitely.
Um, I think the only thing we were missing was scary music in the background, but
Oh boy.
I think
I think we're
yeah,
okay with that one.
it's time for me to sign off though. Yeah,
Oh yes. All
right.
right. Thank
So
you so
everybody
much,
have a good day.
Rich. Yes. Bye.
Happy Halloween.
Bye.